For the past 20 years, LEGO has been extremely conservative about innovation. LEGO is known culturally for the bright, colorful and creative universe. Yet, if you compare the sets released in 2020 to the ones released in 2000, well, mechanically, experientially they are almost identical, which is kind of ironic for a brand that claims to be about creativity. So I wanted to prove something. I wanted to prove that LEGO could be upgraded with modern AI. And then I had the idea. What if I built a self-driving LEGO car? This video is the engineering story of how I actually did it. And this is not a simulation, this is not a fake post-editing demonstration. This is a real LEGO car physically moving and navigating on decisions produced by a deep learning model. The design philosophy is actually pretty simple. The car drives itself, but I also want the user to be able to interact with its behavior. So I'm going to build 3 layers: car itself, mobile app, and a relay computer that will handle all the EV maths. That is the architecture. For the car itself, I needed one motor for steering, a motor for gas, and a camera. I plugged all of them to a chip with onboard antenna and I powered it with battery. Just that we basically already got a raw prototype. But I wanted the thing to remain visually and emotionally LEGO. So I took this whole LEGO pickup I got when I was a kid and I mounted a camera on the roof. I removed the long back to increase maneuverability and I rearranged the chassis. So now it still visually looks like a toy but with a computer vision pipeline. It's not perfect, but it works. Now let's talk about the most interesting part, driving logic. I decided to base my system on deep learning for one main reason: lighting variance. For those of you who have trained that kind of model already, well, you obviously know what I'm talking about. Lighting variance actually destroys brittle logic. Rooms get darker, sun goes down, shadow moves, the whole atmosphere changes. But deep learning can adapt to that kind of change thanks to generalization. Now, very quick reminder of the core principle, and I promise I will keep it as simple as I can. Classic programming is about defining rules that will transform inputs into outputs. Machine learning reverses that logic to provide example of inputs and example of outputs, and then computer will invent the rules for you. Those rules are called a model. Once the model is trained, you can then use it on inputs it has never seen before, which is exactly what we want. So once the chip is programmed, we stream the live video directly into the computer. Then I build a free ride mode on the app. The phone will receive the images and will also send the controls to the car. From this moment, we can start recording data. Images go into a folder, frame by frame. For the steering and gas values, they are saved in a CSV file, same indexing. So the dataset coupled images, steering and gas values. After that, I train my model to predict gas and steering values directly from those images. And I would have liked to tell you that it worked first try, but obviously it did not. Why? Because of a dataset issue. All my images were recorded during the same time of the day, so when I tested it, the distribution of lighting in the video stream were different from the distribution of lighting in my training set. To fix it, I collected more data from different time of the day, of course, with different lighting. Performances were much better like that. And after a couple of new training to handle better sharp turns, we officially got our self-driving LEGO car. Up to this moment, the car was self-driving, but only on the main road segment. It followed the road in front of the camera, but it will never take any side branches. So, to let the car explore the rest of the road network, I need a way for my system to know where turning opportunities exist. And that is exactly where mapping comes in. I train additional models to detect lanes, turns and crosswalk, especially crosswalk tiles, because those ones have side openings. Those side openings are basically like gates to other road segments. So the pipeline is simple. It detects the crosswalk in the video stream, it saves their position, and then it builds the map with those detections. Once we have the map, we know exactly where crosswalk tiles are. I had a small pathfinding logic so it can compute the best itinerary for any tile on the map. After this step, the car stops being a purely reactive agent that only follows the road it sees. It becomes a planning agent that can leave the main road and take side branches, and that way it can explore the rest of the road network. Then, to start the autonomous drive and building the map, I simply press this new map button. Once it's done, I have the ability to place buildings all around the road types. I built 6 buildings for now, but this system is obviously extensible. I also improved the map builder to store the tiles orientation and size openings. So now we can say go to this precise tile and the system will compute the routes. One last thing I want to highlight, because honestly, this one feels completely crazy. Once the car had mapping and pathfinding, I just realized something. The user should not even have to use buttons. So I built a vocal agent. It can be accessed through the button here called the driver. The vocal agent passes your intent.
Hello, sir. Where can I take you today?
Hello, sir. Who are you exactly?
I am your driver for today. I know this city by heart, so you can ask me to take you anywhere you want. I will take you there safely and quickly.
Well, then let's go to the apartments, please.
Got it. Let's go to the apartments. Fasten your seatbelt.
It extracts the target location and then it sends it to my system. Then the system finds the best itinerary thanks to the pathfinding. You don't use buttons anymore, you don't select coordinates, you just speak like you would do to a normal human. This is the moment where the project jumped from a nice engineering prototype into something completely new. A Lego vehicle with a mind with whom you can not only interact but speak with. I wanted to prove that Lego could be upgraded with modern AI, and this is the proof. This is a Lego toy running a real computer vision pipeline, building its own world and navigating in it. This is actual deep learning applied on real plastic brick. I hope you guys enjoyed this video. I am currently looking for a job in machine learning, so if you know someone who could be interested, please send them this video, I would be grateful. Otherwise, a like or a comment is still appreciated. Thank you for watching.